Hey everybody, how's it going? I hope that you all are doing really well. I know that I'm kind of finding a rhythm finally, which is nice. It's been an adjustment for sure, but I think I'm finally hitting my pace and finding a groove. Hope the same for you all. A couple things I want to remind you of. Obviously, we've got some here on the screen. But hey, if you would be an encouragement to your friends, the people that you know, whether closely or acquaintances, be an encouragement to them to get their stuff done, especially on the day of. Now that we have our deadline of the next day by 8, it's super important that you're getting the stuff done. If you have questions, you can always email and or communicate with me via Google Hangout. So make sure you do that. Okay, let's go over these couple things, and then we're going to dive into the lesson for today. All right. Um, Here's the big thing. Okay. And I sent an email out with this information. It says assignment and attendance check are due the next day by 8 a.m. Okay. So for all of you A-dayers on Monday, your assignment and attendance check is due Tuesday morning by 8 a.m. All right. So if you are in my class that day, remember to adhere to the deadlines. All right. The great thing is, if you get confused, the due dates in classroom are going to reflect when these two things are due, the assignment and attendance check. Okay. The attendance deadline is firm. So if you don't have that attendance check completed by 8 a.m. the next morning of the, after the day that you're supposed to be in my class, then you'll be counted absent. All right. There's no going back. There's no, hey, I forgot to do the attendance, but I turned in my work. We've got to work together and we've got to hold firm to these deadlines. So make sure you get that done. Hope you guys are staying safe. Hope you are being cautious and not spending time with people. It's getting more and more severe. So just take care of yourself, okay? And do what the CDC and the government is saying. Do what common sense says, right? If this thing spreads from person to person contact, stay away from people, whether you have it or not, whether you think you're vulnerable or not. Please do your part, okay? Which is basically stay isolated. I know it's tough, but we have so much technology, it really doesn't feel that lonely if you have folks to connect with. So, all right, I'm going to jump off of here, get rid of my face here, and then we're going to jump into the lesson, okay? Please make sure you're paying attention to these. All right, here we go. All right, so lesson 7.3. All right, this is part 2. All right, part 1 was last week, and then we're going to do part 3 on Wednesday, Thursday of this week. Okay. All right, so let's jump straight in. All right, it says solve the given equation by taking a square root. All right, so this was part 1, where we see that the x squared is on one side by itself, and then we have a constant or a number on the other side. Okay, so we're going to I'm going to rewrite this down here. All right, so take the square root of both sides because this is already isolated. Okay, so the square root of x squared is just x. And then the square root of 72, all right? It doesn't have a whole number as its answer. So I'm going to jump over to my calculator. All right, the square root button, I guess it doesn't matter because you don't have a TI-84 in front of you. All right, square root of 72, but it's this radical symbol. Okay, so you can find that in so many ways. All right, and this thing says 8.4852, blah, 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 blah. All right, so we're going to round to 8.49. So because it's not exactly, I'm going to change this equal sign to an approximation sign. Okay, so let me move my mouse here. So we're going to round it to 8.49. Okay, all right, and that makes sense because 72 on either side of it is the square root of 64, which is 8. Right, and the square root of 81, which is the whole number 9. Okay, so that is this right here makes sense, right? Because 8.49 falls between the whole numbers 8 and 9. Okay, so this is just these are what we call perfect squares. Okay, 64 and 81. We're going to talk more about those in just a moment. right? But for this one, it's not a whole number, right? So approximately 8.49 times itself is 72, okay? All right, that's our warm up. Here is where we kind of get into something new. All right, we're going to rewrite each radical in simplest radical form, okay? So the radical, again, is that little symbol. What I want to do first, we're going to create two different rows in a table, all right? So we're going to do factors, and I'm going to list factors. So 1, 2, 3, 4, 5, 6, 7, 8, 9, and 10. All right, so we got 10 factors. All right, this is separate. All right, so I'm trying to get rid of that. All right, and then the second thing we're going to do is we're going to list a set of perfect squares. All right, and perfect squares are whole numbers or counting numbers multiplied by themselves. Okay, so 1 times 1 is 1. All right, 2 times 2 is 4. 3 times 3 is 9. Then we have 16. Then we have 25. Then we have 36. Then we have 49. Then we have 64. Then we have 81. And then lastly, we have 100. Now, these keep going, but we're just going to stop here. Okay, so I'm not going to draw, maybe I should, but I'm not going to draw that line all the way down. All right, so perfect squares are these counting numbers multiplied by themselves. So 1, 4, 9, 16, 25, 36, 49, 64, 81, and 100. Those are the first set of perfect squares that we run into. Okay, so come down here. I'm going to try to leave that on the screen if I can. All right, so we've got those. All right, so rewrite each radical in simplest radical form, right? So simplest radical form just means that we're going to still have the square root or radical symbol, okay? So what we want to do here, we want to take these numbers and we want to find a perfect square that goes into, in this case, 20, right? So 1 times 20, yes. 4 times what number gives us 20? Okay, so this one, we're going to rewrite this one as 4 times 5 because that's 20. All right, 9 doesn't go into 20, so we can't write a multiplication sentence that would work that way. We can't find a factor that goes evenly into 20. 16, obviously the same, and then this 25 is above it. All right, so this is what we're after, right? We have a perfect square, and then we have the other factor that made the 20, okay? So what we do now, we're going to separate these two. So square root of 4 being multiplied the square root or by the square root of 5, okay? So why we can do this is because there's a property called the product property of radicals, right? So if two things are being multiplied together underneath the radical sign, we can separate them both under radical signs and then multiply them, okay? All right, well, the square root of 4 is 2. And then the square root of 5 is, it's going to be some decimal, right? So we're just going to leave that. So it's 2 times the square root of 5. All right, so this is the simplest radical form. All right, let's take a look at 26. All right, so we want to ask ourselves, is there any one of these perfect squares that can go into 26? Well, 25, no. 16, no. 9, no. 4, no. 1. 1 is the only one, right? So basically, we're looking for 1 times 26 and 2 times 13. All right, these are the factors of 26. So none of these, other than the 1, are perfect squares, okay? So because of that, then this right here is in simplest radical form, right? There's no square root of any factor that we can take out besides the number 1, okay? All right, come down here to 18. Let's do 1 times 18, 2 times 9, and 3 times 6. Are any of these factors perfect squares? Well, we listed them up here so that we would have easy access to them. All right, we see that 9 is, so we're going to rewrite this as 2 times 9. All right, and now we can separate those. So the square root of 2 times the square root of 9. Well, we know that the square root of 9 is 3. Okay, so now we have the square root of 2 times 3, the whole number 3. Okay, and then let's see if I can turn off this light. That's not helpful. Okay, and then since there's no way to break this down and the square root of 2 is not a whole number, we're just going to rewrite these. We always put the whole number out front. So 3 being multiplied by the square root of 2. And that's our final simplest radical form. All right, the last one is 116. Now this one's nice because we actually have to do some thinking here. All right, so we've got 1 times 116, 2, and I don't have these memorized, so I'm just going to divide it in my calculator. 116 divided by 2 is 58. 116 divided by 3, I'll put it over here for you. 116 divided by 3 is not a whole number, so it's not a factor pair. All right, 116 divided by 4 is 29, so we've got 4 times 29. 116 divided by, not 5 because it doesn't end in a 5 or 0. So let me jump to 6. Not a whole number, so not a factor pair. 116 divided by 7, not a whole number. 116 divided by 8, not a whole number. And 116 divided by 9, not a whole number. All right, so we found the factor pair we want to use. So I'm going to rewrite this as the square root of 4 times 29. Okay, so we can break these apart. So the square root of 4, and we're going to multiply that by the square root of 29. Well, we know the square root of 4 is, square root of 4 is 2 from our table up here, right? So we're going to say 2 times the square root of 29. We could leave it like that, but most of the time we get rid of the little dot because anything next to something else is always implied multiplication. Okay? All right, 2 square root of 29. Okay? So this is simplest radical form, right? So you're basically looking for a factor that is one of your first 4 or 8, it's one of your first 10 perfect squares. Okay? So you try to break these numbers down into a perfect square times another factor. Okay, if you can do that, then you'll get a number to the outside of your radical like we did in these couple of examples. Okay, all right, let's turn it over to the back. All right, let's see. All right, this says solve each equation, give answers as both an approximation, rounded to the nearest thousandth, and in simplest radical form. All right, so we've got 2 different things to do. I think you can see so much better without the light. Okay, so we want to know the value of x. Let me focus this. Still have not mastered clarity with this silly ladybug. Should not be this hard. All right, so we've got x squared equals 150. What we're going to do is take the square root of both sides. And I may actually switch over to notebook paper. All right, that's what I'm going to do. All right, so the square root. So the notes, it is x squared equals 150. Okay, take the square root of both sides, and you get x equals, well, we want to write this in 2 different ways, right? We want to write this in 2 different ways. So the square root of 150, I can literally find that in my calculator. Square root of 150 is 12.7. You can't see my calculator. I'm sorry about that. 12.24 12.247. So it says to round to the nearest thousand, so we're going to say 12.247. Okay, so because of this, I'm going to change this to approximation. Okay, and then we're going to find it in radical form, right? So remember, we want to find a perfect square that goes into 150, all right? So you'll find that 150 is not divisible. So 150 divided by 1, and I'm going to do a table here. So 150, we're going to do 1 times 150, 2 times 75, no threes. 150 divided by 4 is not a whole number. 150 divided by 5 is 30. So 5 and 30. Still don't have a perfect square. So let's do 150 divided by 9, which is a perfect square. 150 divided by 16. 150 divided by 25 is 6. Okay, and 25 is, all right, so we have 6 and 25. All right, so this is going to be how we rewrite this. So now this is going to be the square root of 6 times 25. Zoom out a little here. Square root of 6 times 25. Okay, and then I'm going to split this up. So now it's going to be the square root of 6 times the square root of 25. And we know the square root of 25 is just 5, right? We don't have a whole number for the square root of 6. So again, we're going to rewrite this. Let me move this up just a tad. We're going to rewrite this as whole number out front times the square root of 6. Okay? All right, so that is number 2A. Okay, number 2A. All right, now let's go do 2B. All right, I'm going to rewrite it on notebook paper. It just seems to be easier to see. All right, so we've got, I'm going to change the page here. All right, so we've got 2x squared equals 588. Okay, so we can't take the square root yet because we have to get rid of this 2. So divided by 2. So I have to come off to the side and do this on my calculator. So 588 divided by 2. So we have x squared equals 294. Okay, now we can take the square root. So the square root of x squared and the square root of 294. Well, this is x. And we're going to do our approximation first. So it's approximately. So the square root of 294 is 17.146 approximately. Okay, so this is one answer. Now we've got to break this thing down. Okay, so I'm going to create a factor table, 294, and I want only the perfect squares, right? So I'm going to do 294 divided by 4. That's not a whole number, so I'm not going to write that down as a factor pair. 294 divided by 9 is not a whole number. Okay, 294 divided by 16 is not a whole number. 294 divided by 25, I'm not going to even do that. I'm going to do 36. Okay, still not there. So 294 divided by the next one is 49, and we have one. All right, so this is 6 times 49. All right, so those are the factors. Now, why did I skip all those other ones? Well, 1, because they weren't whole numbers, and 2, because I'm only looking for perfect squares. So now I'm going to rewrite this, okay, as x squared. Oh, I don't have to do that part. The square root of 294 is the same as the square root of 6 times 49. We can break these apart, so we can take the square root of 49 by itself. All right, square root of 49 is 7 times the square root of 6, right? We're leaving this as a radical because it's some decimal, right? So we're going to leave it in radical form. So 7 times the square root of 6, okay? All right, and then our last one on the lesson sheet for this particular section is this x squared, all right, minus 7 equals negative 9, okay? So x squared minus 7 equals negative 9. All right, I'm going to add 7 to both sides, add 7, and that gives me x squared equals negative 2. Well, what did we learn from the second video I sent out on Wednesday, Thursday last week? Okay, we cannot take the square root in Algebra 1 of a negative number. Okay, so this is no real solutions. All right. And the key word here, again, is real because we only deal with real numbers, right? Algebra 2, you'll see imaginary numbers. Then you can actually do something with that negative 2. But right now, that's all you can do, okay? All right, last one on the lesson, okay? Not too bad. Not too bad at all. All right, I think you can kind of see this one a little better. I'm learning that. Let me get rid of this ladybug. Okay. All right, so I'm going to shield this with my hand. All right, so now we've got a word problem, but we're doing the same thing. We want to eventually take the square root. I can already see where the squared is, okay? All right, Z wants to use paving stones to create a circular patio in her backyard, okay? She knows that she has enough stones to cover 345 4/10 square feet, and we're estimating the maximum diameter that Z can make her patio, okay? So pi is going to be this number, and then we're going to approximate our answer to the nearest tenth, okay? All right, so the first thing we want to do is write down the formula that we were given. So pi radius squared. And notice we're looking for diameter, but this thing gives us radius, all right? So the relationship between diameter and the radius is that 2 radii equals 1 diameter, okay? And that's just information I'm going to give you. All right, so here is our quadratic function, right? We're going to solve by taking the square root. Let's find the values that we were given. All right, 345.4 is our area. So 345.4 equals pi, which is 3.14. 3.14 times the radius squared, all right? So we can't take the square root yet because we've got this 3.14. Divide by 3.14, that creates a 1. Divide by 3.14, over your decimal. All right, and that number is 110, all right? And that's your radius squared. All right, now we can take the square root, right? So take the square root of the 110, take the square root of the r squared. This one's the easy side. Square root of 110 is 10.5, all right? So it says round to the nearest tenth. So we're going to do 10.5, okay? And that's going to be feet. So that's how long her radius is allowed to be. But remember, we're not looking for the radius. We are looking for the diameter, all right? So let's take a look at this. Diameter is just going to be 2 times the radius. So 10.5, all right, times 2 is going to end up being 21 feet. All right, so she is allowed to build a patio that has a diameter of 21 feet. So if this is her circular patio, right, 21 feet is going to be this length across the very center, right? 21 feet. All right, and each of these sides, so this is 10.5, this is 10.5, right? But the 2 radii together give you your diameter. All right, so that concludes lesson 7.3, part 2. Okay, just a couple of reminders now that I kind of figured out the ladybug. I've got to shade it with my hand, okay? All right, so to find the simplest radical form, you need to break each of these numbers inside of the radical down into a perfect square times some other factor, okay? You can do that by dividing your number by each of the perfect squares. Okay? So we divided 20 by 1. Obviously, it's 20. 20 by 4 is 5. And then that was the only one that went evenly into the number 20. Okay? Then we break apart this, giving both of these numbers factors a radical. The square root of 4 was 2. The square root of 5 didn't have a whole number, so we just left it in simple or simplest radical form. Okay, so 2 times the square root of 5 is the answer for this particular one. Okay, so please take your time on this video, pause it. Remember, we're finding factors where one of the factors is a perfect square, because we know that we can always take the square root of a perfect square, right? And it's going to be one of our counting numbers, okay? And it's going to be a whole number. All right, guys, hey, make sure you take care of your stuff. Get your attendance check in. By the way, the attendance check answer is going to be, trying to think. What holiday is coming up? What celebration or celebratory holiday is coming up in the next week and a half, 2 weeks? Actually, 2 weeks from Sunday, yesterday. 2 weeks from yesterday, we have the holiday coming up. What is that holiday? I'll give you a hint. It starts with an E. All right, guys, have a great day. Get your stuff done. Attendance check. Meet those 8 a.m. deadlines. And I will talk to you all on Wednesday. All right, bye.